Okay. So your homework assignment, has a folder. I have not uploaded this yet, so it will be uploaded, as soon as I can in the lab. But I can show you all the files and also how you can, set up your project. Okay, so when you download and uncompress the file, you will end up with a folder called BST, that stands for Binary Search Tree. And inside you will find these files and a particular folder. C is a folder that contains all the C files, and the root or the parent folder has symbolic links to the files in the C folder. So this way you can replace files one by one with your assembly programming file, your assembly language files. The most important part is not the make file. The first part you have to really look at and kind of study is the node.h, the header file that defines the structure itself. Particularly, take a look at the struct node. It only has 3 members. The first member is an integer 32-bit integer b. The other 2 members, one is called PL, pointer to the left, and the last one is called PG, which stands pointer to the greater than sign. Okay, greater than versus less than. And those are pointers to a struct node. Are we doing okay so far? As far as the data structure itself is concerned. The good news is, in assembly language programming, a pointer is a pointer. Doesn't matter whether it's a void pointer, a pointer to a character, pointer to an integer, or a pointer to a structure that you are in. It doesn't matter. A pointer is a 32-bit thing that contains an address. That's all that you need to know from the assembly language perspective. Are we doing okay so far with this? Okay. Do we know how to implement this node in assembly language? In other words, is there a way to figure out the displacement of PG from the beginning of the node? Okay. What if I test your code by changing this file and shuffle things around a little bit? Can you make sure that your assembly code is insensitive to the ordering of these things?
Using that fancy.
In other words, when I test your program, what I will do is I'm going to change this file. I can do something like this. I can say char a bracket 10 and just stash it here. I can put it here. I can put it here. I can reorder things a little bit like that. None of these operations should render your code incorrect.
So we've got to write that thing you did.
The generator thing. Yep.
The C, that's C.
The generator program is the header file generator program. The include file generator program that we talked about last time.
Yeah.
Do you guys still remember how to do it? No?
Can you give us the link to the YouTube videos?
I'm downloading it right
I think that I might have uploaded already.
It is.
Just last
Yeah,
time.
but I haven't found any of these YouTube.
SOMEPRO, that's just YouTube subpros. It'll show right up.
Okay. So that's the first thing you have to do is to write that kind of stupid program that has like a bunch of printf statements, right? And that's it. Okay. The make file is already set up for you. Okay. If you look at the
Thank you.
okay.
I've never done a make file that's looked anything like that.
It's a nice, beautiful looking make file.
Yeah, mine looks.
That's how I describe it.
The make file is already set up, so everything is set up already. So if you do a make, of anything, including the include file itself, like node.inc, just say make node.inc, and it will do everything for you. Then you will say, attack, you're giving me that node inc gen.c file already, so it's all done. Well, let's take a look at that file. Node inc gen.c. That's what it is. Now I'm definitely kind enough to give you the #include stdio, so you can use printf, and also node.h, so that it includes the correct definition of the structure.
And you're not making us write this in assembly.
And you're not writing it in assembly. Well, that becomes cyclic because you can't really do it in assembly because this is here to generate the include file, so you know exactly where things are in the structure to begin with.
Sure,
So this is one of those things where it is not a good idea to write it in assembly. Is that making any sense?
Yeah, I see conflict.
Okay, so you need to populate this particular file with 4 printfs. one to print member V, one to print member PL, one to print member PG, and one to print the size of an entire structure.
In C.
Hmm?
In C. In C.
Written in C, yes. This is a C program that you have to write, which will so you have to add 4 lines to this program to make it work. Okay? So the output of this program is redirected into node.inc and uppercase N-O-D-E.inc, and your assembly code will have to include that file, so that any change to node.h will trigger a change to node.inc, and as a result, your assembly code will get recompiled or reassembled to make everything consistent again. Yep.
Oh, so we're just redirecting it.
Yep.
So we're not doing f print s or anything crazy.
Not fprintf, just
Okay.
printf. Well, printf is fprintf with standard out as the file handle.
So we won't have to shuffle around the makefile like you were doing last week?
Hmm?
We won't have to shuffle around the makefile like
Nope,
you
the
were doing
makefile
last
is
week?
already done.
Alright.
Yep. So if you look at this makefile, okay, you do have to replace the files one by one, okay? But the way you do it, when you replace a file, let's say you want to deal with BST read first. So you just take this out of here, add into a src assembly source file, bst read.uppercase s. You have to create that file first. And then what you do is out here, you say rm bst read.c, because you want to remove the file itself from this folder so the make file doesn't try to pick it up again. Okay? Now, it's not a big deal if you do this, and then later on you say, wait, I want it back, because I want to look at the C code. The C code is actually in the C subdirectory. So when you look at the C subdirectory, it has all the C code already. And what you're removing, what I just removed, was a symbolic link to this file in the folder C. So don't mess around with the files in the C subfolder, because those are the actual files. But everything in the other level, they're all symbolic links. When you see this little pointer thingy, that points to another file in another folder, it means it's just a symbolic link. So that means, if you deleted something that you really did not intend to delete, you can just reestablish the symbolic link. I'll show you guys exactly how to do it. Yep.
Is it similar to shortcuts in Windows, or different? What is it?
It's kind of like a better shortcut than shortcut. But yes, it is the same concept, it's the same idea. So if I want it back, I can just say ln-s c/ and then the file name. In this case, I think it's bst read.c. And now I have that file or the link back into this folder. So you can remove a link, you can reestablish a link, but my suggestion is once you remove, you just kind of leave it alone. If you want to see how the program runs, there's one quick and easy way. Change to the C subdirectory, say make, and then run the program like that. Okay? So the C subdirectory is set up just for that purpose. Okay? Everything is specified in C, it works, and then you can just use it for testing and debugging purposes. You can run GDB through the whole thing, so you can actually see how the logic flows in the C version. When you run the program, it reads everything through, from stdin or standard in, and you just have to give it a bunch of integers. That's all it takes. So you can give it any number of integers. So 4, 7, 1. It can deal with negative numbers, like -6, 7, 2, 10, -6. And when you're done, press Control D, and it will print all those numbers back out again, but in a sorted order, because it is traversing the binary search tree in the order that we just talked about. Are we doing okay so far? That's what the program does. It reads a whole bunch of numbers, sorts the number using binary search tree, prints everything back out. That's it.
All the C files were dropped on the convert.
Yep. But they're not really difficult programs. Okay. So let's take a look at some of the files here. Main is the only one that you do not need to convert. Okay. You can see that main is really simple. All it does is to read from a file and make a binary search tree. print the binary search tree and then destroy the nodes in the binary search tree. That's all it does. And because I'm not now including setting in or some of the other files, null null is not defined, and that's why as a pointer, root is initialized to 0 instead of null. So this is one that you don't have to do any conversion. And let's look at, I don't know, I cannot imagine any one of these is particularly hard, but let's take a look at read. Okay, this is the read subroutine. The read subroutine is the only one that is non-recursive. So if you want to get warmed up first, this is the one to get warmed up with because it has no recursion in it. It has a loop, a do-while loop. It has a local variable I. It calls scanf. How do we call scanf? The same way you call printf. Okay. How do we deal with that literal string? Double quote, %d, double quote. The same way you did with that. Okay. So a lot of things that you did already will work here. The only question is how do we do that ampersand I? How do we push the address of local variable I on the stack? Remember, I is an auto local variable, which means it does not belong to the dot data section. It belongs on the stack itself. So
Frame pointer plus.
there are several ways to do it. You can calculate the address in a register and then push the register on the stack. You can also push the offset on the stack and then finish the calculation on the stack. I think we talked about this already when we did the swap subroutine. So you might want to kind of look up the notes. I can upload the files again if it is not on Moodle yet. So individual pieces are already there. You just have to kind of figure out how to put all the pieces together. Now also take a look at the prototype. The prototype of BST read is proot is a pointer to a struct node. Okay. Don't let that bother you because if you look at how proot is used in this particular program, it's fairly straightforward. Okay? Particularly, look at this line here. This is the only place where proot is actually used in a subroutine call. So in assembly, how do you do this? How do you call BST insert with I and proot? You just push them on the stack. Does it say anything about dereferencing? No. Then you don't have to do any dereferencing. Does it say anything about taking the address of something? No. Then you don't have to take the address of anything. So whatever the parameter is passed to you, push it on the stack and pass it along to BST insert.
When will it be due?
Sorry?
When will it be due?
I'm tempting to make this due next Tuesday, but I think that might be a push. But I don't want to make it due on the final day. Well, I guess that would be fine because this is good material to go through to study for the exam. I'll put it that way. Huh?
Do you know what our final is?
The final is the last day, I think.
2 weeks from now.
2 weeks from now, so that's plenty of time.
Yeah.
Is it comprehensive or?
It's comprehensive. Comprehensive except for memory cycle up that stuff at the very beginning that has no programming whatsoever. That stuff is not going to be in the final
So
exam.
let's say from the stack on.
Oh, okay. Yeah, everything about flags, the stack, the frame, dealing with structures, those will all be in the final exam. And that's why this program is going to be helpful because it will prepare you for all of those questions. Okay. Well, since you guys are ready to leave, I'm going to talk about this on Thursday. So on Thursday, we'll take a look at this program again because it's a good review of everything that we learned in this class. So
if I have a question where I got wrong, I just see the lab.
yeah, okay. I'll just go to the lab and we can talk about it.
Change the lab.
The lab?
Hey, I think you